Hello everyone and welcome back to GOTO Book Club. My name is James Lewis and I'm here today with the author of data-oriented programming, Yehonathan. Did I get your name right? Apologies if
perfect.
I the pronunciation.
You did perfect.
Welcome to GOTO Book Club.
Happy to be here.
So we're here to talk about your book. Can you just give us a brief introduction to the content?
Yeah, so first of all, it's my first tech book. Maybe it will be the last one, I'm not sure. I did it with Manning, and I quite enjoyed it. It took around 2 years to write the book, and Manning has this very interesting early adoption program. So I didn't have to wait until the book is totally completed in order to get feedback and see how many book copy I sold. And I'm a developer and I'm in the agile world, so I need immediate feedback. I'm not sure I could have waited for 2 years before getting any hint. So after 3 chapters were published, it was launched and people bought it and wrote about the book, what they like, what they don't like. And I was able even to change a little bit the table of content based on feedback. So I really, really enjoyed the process.
So it's almost like a lean pub type process where you get very, very early feedback. Yeah. Awesome.
Yeah.
Maybe you could just give us a brief introduction to yourself as well for the folk out there who.
Yeah. So I'm around 40-something year old. I have a family. I live in Israel. I've been a developer for more than 20 years. I started with C, C++, and then got upgraded to Java. And then upgraded to JavaScript, but I started to see the light when I discovered Clojure 10 years ago. And it made me so... I like to say that there is a before and after Clojure for me. Before 10 years ago, programming was just my job, and since then it has become my passion. I really, really enjoy programming. I like to write insight in blog posts. Programming has become fun again.
And what is it you think about the Clojure programming language in particular that gives you that kind of that real buzz?
Yeah, so that was kind of difficult to nail it down and so I discussed that with the Clojure community after my attempt to write a book about Clojure with Manning, an attempt that didn't succeed. So there was an early program launch, but 100 people bought the book overall. So Manning told me, look, we like you, but we cannot make business with you. So can you come with another topic for the book? And I said, okay, I cannot convince people to adopt Clojure, but I like it so much that there must be something in Clojure, like a universal paradigm that I could share with the community of developers. So I spent a couple of weeks and months with Manning folks and with Clojure developers to figure out, is there a way to formulate Clojure principles in a non-Clojure way? And that's what data-oriented programming is about. So it's a way to get all the Clojure goodies without having to learn Clojure syntax.
So when we were talking before, you talked about the principles that you set out. Maybe you could talk through some of those principles.
Yes.
That would be...
Yes. So just before the principles, what is the goal of each program paradigm as a goal? It's not that it's the best thing for everything. So the goal of data-oriented programming is to reduce complexity of information systems. And complexity, not the O of thing, not the computational complexity, but more the system complexity. By that I mean the amount of suffering that you experience when you try to understand a system or to add new features to a system. So that's complexity. And my claim is that if you write your code following data-oriented programming principles, then you will reduce the level of complexity. Make sense?
No, it does make sense, yes. So when we talk about complexity, we often talk about the difference between accidental versus essential complexity.
Right.
So are you talking about the same sort of complexity then?
Yes.
The stuff around
the essential complexity, if you want to reduce it, you have to move to another problem. But assuming that you are forced to solve the current problem, you cannot reduce the essential complexity, but you can reduce the amount of accidental complexity that you add to your work. So yeah, we deal with accidental complexity.
I mean, I think maybe some other people would argue as well that that actually some programming languages are better at dealing with certain types of essential complexity.
Right.
As well, right? I mean, if you found out with Clojure that you actually get to solve problems in a slightly different way with Clojure when you...
Right.
Full disclaimer here, I have actually written Clojure code. I'm not entirely ignorant of writing Clojure, so... but yeah, I mean, is when you write Clojure, do you find that there are certain problems that fit it more?
Yes, so this kind of problem is that what we call the information system. For example, a backend software that takes data from the database, manipulate it a little bit and pass it forward, or a front-end application with a state that we need to manage. It's not, I don't think it's a good fit, data programming, for writing databases or writing embedded systems or routers or stuff like that, where you need a highly computational thing, and when performance is the key. But when you manipulate data here and there, and when you... Also, one important aspect of it is that when your program manipulates data that it doesn't own, when the owner of the data is another system. For example, the database is the owner of your data, and your backend only has to pass data around. If you write a compiler, for example, you own the data. You know exactly what is the structure of your data. Yeah. There is no surprise. So for that kind of problems, I'm not sure that oriented programming is a perfect fit. But for dealing with the real world and surprises of the real world, I think it's a good fit. We have a sort of old joke in Thoughtworks, which is 50, maybe even 90% of our job is taking data from A and moving it to B. Right. And the other 10% is showing it at C, right? I mean, that's exactly. Pretty much what most enterprise software developers do. Exactly. So for that kind of stuff, I think Clojure has been known to be good. But the problem with Clojure is that it has a reputation of being hard to learn, or it's a different mindset. So it's hard for, let's say, Java developers to move to Clojure. So I hope that with DOP, it will bring Clojure way of thinking to non-Clojure developers, and we have the tools for that, as we will maybe talk about later. Yeah. The key thing in terms of code that we need is the immutable data structures that were invented by Rich Hickey when he developed Clojure, or discovered. But since then, it was in 2009. Since then, they have been ported to any programming language. To Java, Ruby, Python, JavaScript. So we have all the tools for that. We just need to make the leap. I guess to recap a bit, so the goal of the book is to introduce the way of thinking that Clojure developers use, if you like, when they're writing Clojure, to introduce that to a wider audience and to give a wider audience the sort of tools, the mental tools to think about problems in a way that... and solve problems in a way that you might solve with functional programming. Both the mental tools and also the technical tools, so that you can implement. In the book, I use JavaScript as an example. Right. Yeah. And when it really matters, I illustrate also how to do it in Java. But JavaScript is easy to read by anybody, so I use it more as all the code examples in the book work, but it's more like you can read it as pseudocode in order to get a real sense of that it's not only abstract principles, it's pragmatic. It's things that you can do tomorrow morning. So it's both the mental tools and the technical tools. And also the motivation. The way I wrote the book is... so I had a problem. When I started to write the book, I was over-enthusiastic. Yeah. I thought it was the best thing, the material was the best material in the world. And I wanted to convince, and when you are too convinced and you want too much to convince, you are not convincing. So the publisher told me, keep quiet. and then they asked questions. The person that worked with me from Manning asked questions, objections. Here you have a problem, here you have a problem, it's not a perfect fit. And then I kind of become schizophrenic. So on the one hand, I'm enthusiastic. On the other hand, I have lots of questions. How am I going to manage it? And I came up with this interesting idea to give voice to both sides in the book. So,
right, okay.
And I wrote the book as a story, as a meeting between an old or a 5 or 10-year Java developer that struggled at work. He worked for a consulting company like yours, but the name is Albatross, I think, in the book. And he has a problem to meet deadlines because of complexity. And then he meets Joe, a Clojure guy, that is very enthusiastic and wants to give him, to reveal all the mental models from Clojure, but to formulate them in a non-Clojure way. So the book is the story of their meeting. And not, and the guy is not a yes man, the Java developer. So he asks many questions, and the Clojure coach, the DOP coach, has to refine his insights and teachings. And it allowed me to manage the two voices inside me to make it, a dialogue.
That sounds like a really interesting approach. So it's almost like it's almost like what we would call a business fable in some senses.
Yes.
So I think
like the goal.
Like the goal, exactly. Like that sort of structure where you have someone who's sort of taking the individual on a journey towards enlightenment.
Yes. And actually it goes back to Socrates.
Yes, then the
like
dialogues.
The dialogues.
Yeah.
Right.
Yeah. Super interesting. So we've heard a bit about what the goal is, as it were. But also, I mean, so you sort of said about some of the tools, the sort of mental and the sort of the technical tools and principles and things. So maybe you could talk to us a little bit about those.
So there are basically 4 principles that we could summarize as one meta principle that can be expressed in 4 words.
Right.
Treat data as data. So that's data-oriented programming. That's very simple. Treat data as data.
Treat, I would say data. So I would say treat data as data. No, data is.
So treat data as data. Maybe, or treat data as data.
Yeah. So treat data as data. Treat data as data. Okay. Yeah.
So
maybe you could unpick some of that for us.
Yeah, sure. So basically, what does it mean to treat data as data or data as data? It means that data is a first-class citizen. Like in object-oriented programming, objects or classes are first-class citizens. In functional programming, functions are first-class citizens. In business class, rich people are first-class citizens. So here, data is a first-class citizen. And what does it take? So it takes 4 principles. Principle number 1 is to separate between code and data. Unlike what OOP teaches, or has taught for years, we don't want to encapsulate data and functionality together in objects. We want data to have the right to live on its own. And then, the cool thing is that the behavioral part of your system becomes stateless. Stateless functions or stateless methods. And as you probably know, state is the number 1 enemy. So we cannot avoid state, but we want to tame it by localize it. So only some slight pieces of our code will deal with state, but all the other pieces are stateless. And it's it's like a dream for unit tests, for debuggability, for code reuse. So that's principle number 1. We separate between code and
treat data as a first class. As the first class.
Yeah, it's not enough. It's a required condition, but it's not enough. So after we have done that, that's principle number 1. Comes the question: how are we going to represent data? Would we use structs like in C? Will we use records like in modern Java? Will we use dictionaries like in Python? So the answer that DOP gives is generic. We use generic data structures. Hash maps, dictionaries, arrays, lists, stuff like that. We don't need anything more to represent our data. Principle number 4 will deal with the limitation of it. But before the limitation, let's drill down into the advantages of it. So first of all, you can create data as you go. You don't have a ceremony before you create data, right? Like with numbers, when you create a number, 42, and you want to add 1, you are not creating a class of even numbers, or even numbers bigger than 40, or even numbers bigger than 40 and less than 50, right? You just create the number. You have the right to create it. And you can manipulate it, and you can pass it around. So it gives you lots of dynamism and flexibility. Also, you can manipulate 42 with all the operations that are there for you. Multiplication, addition, logarithm, exponentiation, any complex math function is available to you, no matter if it's part of the language, like the basic one, or it's written with a library. So the same, if you represent data with generic data structures, you can leverage any piece of functionality that has been written by anybody. So for example, in JavaScript, we have this Lodash library that gives you, I don't know, hundreds of data manipulation functions that you don't need to write. Group by, sort, frequencies, remove key, add key, rename keys, map, reduce, all these things. And you don't have to be a functional programming wizard in order to leverage them. So it's there for you. You don't have to reinvent the wheel for each and every business entity of your system.
That's super interesting, actually, because I mean, in my mind, because have been for a very long time, super interested in domain-driven design, right? I'm sure you've come across domain-driven design, and then you're essentially trying to solve similar problems with domain-driven design, but sort of trying to solve them in very different ways. So, for example, one could argue that tiny types would be a sort of almost the opposite approach, right? So rather than just treat data as generic, it's a number or it's a string or whatever it is, right? With tiny types, you would try and you would create a type that encapsulates the
specifics.
Exactly, the specifics of the thing you're trying to describe. I mean, I remember back in years and years ago, back in 2005-06, I turned up at a bank, or even later, we turn up at a big project and you'd see a big code base, and it was all hash maps, and it was all dictionaries, and the problem was it was really hard to reason about all these things in amongst all this, all this sort of giant sort of object-oriented structures, and that's why I think back in 2009 I did a talk with Daniel Tihos North on programming in the large, where we talked about, one of the things to do is to introduce a domain model, right? Because that allows you to reason about the things that you're working with.
Right.
So how do you solve that problem in data-oriented programming, where you want to be able to reason about the businessy things that your code is doing as well?
Yes. So that's a great question. That's the most challenging question. And that's principle number 4. So let's go to it, and then we come back to principle number 3. Who cares about order? So, when you have small code, when you do homework for university, that's fine. You have a hash map, and you know what the hash map, what are the fields, and you don't have surprises. But when the team grows, when the code base grows, you have a function. Amount that receives something called user. Maybe it's called user, maybe it will be called you, and it's a hash map. So how do I know what are the fields in this hash map? If you are lucky, you have a documentation string that says, in this user thing, you have a user ID, you have email address, you have blah blah blah. But documentation sometimes not there. And sometimes is inaccurate. The code evolves and someone forgot to update the documentation. So, and for that, object-oriented programming really shines because you have no mistakes. It's part, you can inspect the type, and you have auto-completion, and you have, so that seems to be a problem. So we want data validation, right? Another problem is that if you don't do data validation and you have mistakes, you will encounter the errors down the stream. So instead of having the error in the amount function and say, oh, the user is invalid, you will have a foo function that says X is not defined. What the hell does it come from? I've done that. That's the problem of dynamic languages.
Yes.
And in fact, quite recently, I would say over the last 5 years, there have been development and awareness in the dynamic programming language community that we need something. We don't want the limitation of static types, but we don't want also the far west of the dynamic types. We want something in the middle, or maybe we want both. And there are ways to have, how do you say, to cut the cake?
Both have your cake and eat it.
Yes, so there is a way.
Yeah.
And the key is to separate between data representation and data validation. So we want both, but we don't want them to be entangled. Someone commented on my book that every paradigm or good design principle is about separating things. So here again, we want both data representation and data validation, but we don't want them entangled. We want them separate. And we will decide, we the developers will decide when we want to validate this piece of data. And sometimes we don't want. Sometimes we have a function that is just a utility function and it could handle various kinds of data. Because, let me give you an example of that. You could write a function that receives a hash map and receive a list of keys that need to be renamed or removed. So it works with any hash map, not only with users and books. So this function, you want it generic. You don't want to limit yourself in any way. On the other hand, you have a function called checkout, and it receives a card. And you don't want this function to work with a user. It has to be a card. So there are schema languages, like JSON schema, that allows you to express the schema, the expected schema of your data as data. And there are libraries that allow you to say, here, I have a piece of data, I have a schema, could you please validate for me that the data is conforming to the schema? And if not, tells me exactly why. What are the missing fields? What are the invalid fields? And we could use it in areas where it's the only way to go. Let me give you an example. If you have an HTTP server that receives a request, you cannot force the user to send you the valid request. You have no compiler over the wire, right? So how are you going to manage that? Here, you have the schema, you have the payload schema, that could be expressed in JSON schema or something else, and you have the user request, which is a string. So first, you deserialize the JSON string. If you are able to make it an object, you move forward. If you're not able, you send an error to the user, invalid JSON. But then you have a valid map that might or might not conform to your schema. So you use these JSON schema libraries and you validate data with the schema. And if it's not valid, you are able dynamically to send in the response body of the error, hey, to send back the error that is created by the library. Like, here I expect a user, it should have a user ID and it should be a number. Here is an email, it's an invalid email.
That's super interesting. Because so how does that work with? Full disclosure, I've done a lot of sort of integration work over the years, and what I'm thinking about here is Postel's law. That's coming into my mind, right?
What?
So Postel's law. So it's from TCP/IP, and then it's been
adapted. Be generic in what you receive and be hard in what you send.
That's
I mentioned it in the book, chapter 12, I think.
Yeah, that's it. And it's one of these things where over the years, when I was involved with building systems that were doing things like parsing lots of XML or JSON these days, we developed lots of techniques which were to only bind to the things that you need in the response that you're getting, right? So say you get a user and the user has a first name, a last name, a full name, a first line address, a second line address, a full address, right?
Right.
Depending on what you want, you either bind to the first name and last name, or you bind to the full name.
Right.
But you don't expect necessarily everything to be there,
right?
Because you don't necessarily need everything. And what that allows you to do is to use patterns like expand, contract for interfaces where you say, okay, as long as you only bind to the things you need, I can add extra fields in without breaking my consumers.
Right.
If you like.
Yes.
So how does
and you don't have to create a new class.
No, exactly.
Probably people know from the Java you have user in database, user for controller A, user for controller B. You have dozens of classes that is just a subset of the field.
Yes, exactly. Yeah. And so you have that problem, but then you also have this thing about how you evolve interfaces between systems, right? So how do you, how are you able to add new fields? You should be able to add new fields to a response without breaking things.
Exactly.
But that only works if you only bind to, if you're using strict schema validation.
Yes.
That's going to blow up, right?
So right.
Does
this
make sense?
And in JSON schema there is natively this concept of required or non-required field. I think that still in Java the nullability is a problem, right? If a field could be there or could not be there, you have problems. In a hash map, either you have it or you don't have it. It's not nullable. In the schema, it could be required or non-required. So it seems to me that it's the proper mental model to deal with systems that communicate over the wire. I must admit that in terms of tools, we are not there yet. Meaning, if you have a function that receives a user and you have the JSON schema of the user, your IDE will not completely be able to autocomplete the field based on the JSON schema. But we are starting to get there. For example, in VS Code, some configuration file for extensions or for VS Code itself has a JSON schema defined for it that is somewhere on the internet. And VS Code is smart enough to give you, as you type, mistakes about the configuration data. So I envision that things like that will happen in the near future in our programs. So you'd be able to write JavaScript, not TypeScript, or Java with hash maps or Clojure or Python or whatever, and without having to bind your types to your code, like new Python encourages us or like TypeScript, you'd be able to somehow express it via JSON schema or another language, and the IDE will be smart enough to give you error and feedback as you type. And then it's what I call, you have the cake and you have cut it together.
So I find it super interesting because we're in the world of dynamic languages here, right? And obviously there's a whole different set of functional programming languages that are statically typed. The sort of Haskells of this world, the TypeScripts in the end now, I guess. And they're all trying to solve similar problems, but they're solving it in very, very different ways. What is it you think about data-oriented programming in particular that gives you something extra, that gives you something different over having...
It gives you I think it gives you the freedom. Because even in TypeScript, when you want to write a generic function, it's difficult. TypeScript, you have to work against TypeScript. I try to use a library like Lodash in TypeScript, and for most of the functions it works, but for some of them, the types are too dynamic that you have to tell them, okay, you know what, it's an any type, don't care, I don't care. And so back to what you said about the tiny types and the big types, I think that we want the ability to have, when you have low-level pieces of data that are generic, to have the ability to say, I don't mind. I don't want the compiler to bother me, and I don't have to do things like that in order to convince the type system that it's okay here. I want to decide. And for the big things, for the high-level business entities where there are no surprises, you want validation, but you want also the ability to deal with surprises or nullability, which I'm not sure that TypeScript or Java are yet there. But I think both communities have to learn one from each other instead of fighting and say, types are good, types are bad, we are better, you are better. No, there is a sweet spot in the middle, and I've been in touch with James Clark from Ballerina. And Ballerina is an interesting language that leverages something called flexible type system, which tries to bring the best from both worlds. It's not static, it's not dynamic, it's somewhere in the middle. And James gave me this great analogy that types are not maps, they are glasses through which you look at reality. But the reality is untyped. And sometimes you could look at the same reality with pink glasses or with blue glasses. And it's the same reality. So back to your example, you have a hash map. And from my perspective, it's a user with just a first name and a last name. So that's my glasses. And from your perspective, it's a user with first name, last name, full name, and address. But the reality is the same. It's just you change glasses. And I think that traditionally, languages, static type systems tend to confuse maps with reality. And you superimpose your mental thinking of the reality and you consider it as the reality. And that's the source of suffering.
That's, who is it, James?
James Clark.
James Clark. So thank you, James. I'm going to steal that. That's totally going into my toolkit for explaining stuff. That's brilliant. So we talked about the first two and then the fourth principle. So we said we come back to the third principle.
Yes. So the third one I think is the easiest one to convince. It's immutability. And I think every experienced developer, no matter if you're from Java or C or JavaScript, would agree that immutability is a value. If you can afford it, it's better.
Yeah.
What's the problem? The problem is performance. And because when we say immutability, we don't mean things that never change. We mean managing changes in an immutable way. And what does it mean? It means, let's say we have a card with two items. And we represent this card as a piece of data. And now the user adds a third item. So managing it in an immutable way would be to create a new card with the third item. And now we have two cards, one with 2 and one with 3. And then the user another one with 4 or 5.
Yeah.
So we have two potential problems. A memory problem, because we could have millions of cards, and computational problem, because each time we create a new card, we have to kind of deep clone the previous card. So it takes time.
Yeah.
So that was until 2009, that was the biggest problem with immutable data. But still, in many cases, performance is not really a problem because your data is not as big as you might think. If you have a card with 10 items up to 100 items, it won't be a problem to deep clone. But when it gets to, I don't know, thousands of items, and in the book I use the example of a library catalog, which could have millions of books, and now you add another book. So since the advent of Clojure, in 2009, we have persistent data structures, which is an efficient implementation of managing chains. I won't go into the details because I want you guys to read the book, but I give you just a hint. It's very similar to what Git does.
Yeah.
In Git, you have this magic that you can create a new commit and it's fast as light, but the whole history is available. And when you create a new commit and you push it, you don't have to a replica of the whole database, right? Yeah. You don't have deltas. It works in a different way. It's called structural sharing. And persistent data structures leverage it in a very smart way. And it's smart in the sense that, like in Git, as a developer, you don't need to really understand the technical detail. So it just works. And it allows, and since 2009, those persistent data structures, sometimes we call them HAMT, hash array mapped tries, TRIES, have been ported to virtually any programming language. Facebook ported them to JavaScript with Immutable.js. It has been ported to Scala, to Python, to C++, to Ruby, to Erlang, to whatever. So it's we have no reason to tolerate the data mutation. And I will just mention it's another way to tame the state. Because if data is immutable, we have less state to care about. So that's principle number 3, to keep data immutable.
Cool. Well, I mean, it sounds super interesting. I mean, my background is in distributed systems, that kind of thing. And one of the things that really attracted me about distributed systems was that it was another way of managing complexity, right? So, when faced with a big problem, chop it up into lots of really small problems and solve the small problems. Sam Newman, a good friend of mine, the author of Building Microservices, he sort of says that quite a lot. And that was one way I sort of settled on in the OO world of solving the problem of having big things that were really complicated and complex with lots of accidental complexity, is to take those things and break it up into smaller bits. This is obviously a different approach to trying to tackle the same problem, the sort of cognitive overload you get when you're trying to think about these large code bases and trying to work with them and so on. There's one thing that always, and maybe this is a bit mean, I don't know, but one thing that I always struggled with Clojure, and I think it's because I'm stupid. I think that's why. Is like more so than any other language I've ever written, maybe barring Fortran 77 back in university. When I came back to Clojure after I'd written it and looked at what I'd written, it was the language I find most difficult to understand the code that I myself had written. Does that make sense? It's almost like I'd write some Clojure and I'd solve a problem in a really elegant, beautiful way in a really small number of lines of code. And then I'd come back a week later and I would have no idea what it did.
I think, does
that kind of resonate?
Yes, I think I had the same kind of thing when I discovered the functional programming and the power of anonymous functions. And I would write a whole data pipeline with 10 lines of anonymous functions that made me feel very smart.
Yes, right.
But that nobody could read.
Yeah.
And it took me a while to discover that probably the better way to write it is to give name to each step and to give name to the function and to call them one after the other. So it might be less elegant, it might be a little bit more verbose, but it's I think it's much more readable for other people or for other versions of myself.
Exactly, future versions of
future version of myself. Immutable version of myself. But in fact, in data-oriented programming, the interesting thing about it is that you don't have to leave your zone of comfort in terms of the way your habits, the way you write code, the way you encapsulate
your favorite
modules.
language.
Your favorite language. It's a different way to represent your data. And if you take into account the principle number 4 about schema and data validation and don't go too much into the wild, then I don't think you will have this problem. You will write code in a way that should feel familiar to you, to yourself, and hopefully you'll have less bugs. Or when you have a bug, or when you want to add a new feature, it will take less headache to figure out what's going on. You won't have to understand the whole system in order to just modify a bit the functionality of a small part of the system.
So what I'm hearing is we should buy the book because it'll teach us how to write code that's going to better enable us to add new features and modify existing codes more easily. We'll hopefully have fewer bugs. These are big promises. I'm certainly going to take a look at your book. It sounds super interesting. But thank you very much. I think we'll call it a day here. And thank you very much for coming into the GOTO Book Club. It's been a pleasure.
Subscribe to the GOTO YouTube channel now and join the experts in person or online at any upcoming GOTO conference using the promo code Book Club. Visit gotopia.tech to learn more.